Hi, in this video we are going to see about how to make an industrial automation monitoring system using this Bolt Wi-Fi module. Let's start. Wait, first let me explain the problem solved by this device. There are a lot of disasters caused by industries and they killed and injured many of the people. These industrial disasters are mainly caused by improper maintenance and monitoring of industrial plants. So what if we have a device that monitors the entire industrial plant and alert us during abnormal signatures in the process and help us to avoid industrial disasters? Let's move on to this project. This is the circuit diagram of this project. Here we use an Arduino as a processor. In our case, it is a chemical industry storing concentrated chemicals in containers. So to measure the amount of chemicals stored in the containers, we use an ultrasonic sensor here. If you are going to use it in a condition of storing chemicals in the form of gas, to measure the pressure inside the container, you can use a pressure sensor instead of ultrasonic. But in our case, the chemical is stored in the liquid form, so we are using an ultrasonic sensor here. To display the status of the plant, here we use an 16x2 LCD display connected to the Arduino. Here we have attached two relays to control the pump because we are going to fill this container with the help of a pump. Here the secondary relay controls the pump and the secondary relay is completely controlled by the primary relay. If there is any malfunction in the secondary relay and the pump runs even after attaining the threshold level, the primary relay cuts the power off to the secondary relay and switches off the pump automatically. And I have also added a buzzer to alert the user. And finally, I have collected the main part of this project, the Bolt Wi-Fi module. Through this module, we can send data through internet from the plant directly to the user's mobile in the form of SMS, voice call or through mail. Now let's code it. We have created two codes for this project, one for this Arduino to control the system and another in the Bolt Python library to send alert messages. So I have written a bit of code in the Arduino IDE and Python. The entire code is available in the description, please check it out. Before making this project, let us check how it works by demonstrating the connections in a breadboard. Let's also make the connections with the LCD display, check with it. To demonstrate the working of this device, I have made a simple setup. Here, bucket under this table is the reservoir containing the hazardous chemical. We have to pump this chemical to the upper tank using a pump without overflowing. Here I have placed the electronics and the sensor on the top of the overhead tank. Here I have fixed the 16x2 LCD display using some screws and placed the ultrasonic sensor over here. And also connected the Bolt Wi-Fi module with Arduino through serial communication. And this is the switch that starts the pump. This is the wire and the tube that connects the submersible pump under the table. Let's power up the Arduino and check whether it works or not. Here we go. You can see the device has been started and the system is ready to use. To power the pump, I have used an 12 volt supply from my 24 volt adjustable bench power supply. Now you can see the system is ready to use. Let's check it whether it works with switching on the system. Once I switched on the device, the pump starts pumping the chemical into the tank. You can see the tank is getting filled. Yeah, that's it. Once the threshold level is reached, the device automatically stops the pump and prevents the chemical from overflowing. Thus the device works quite normal. But when there is a malfunction in the relay or a circuit, and the pumps keeps on pumping the chemicals to the tank, will collapse the entire plant. So we have installed Bolt IoT module to alert the user and the automatic power off system to shut down the system during malfunctions. To demonstrate this, I'm going to short this relay's power supply directly to the primary relay so that the pumps keeps running even after the threshold level is reached. I'm going to check whether it alerts the user or not. As you can see, the pumps keeps on running and pumping the chemical to the tank even after attaining the threshold level. Let's see whether it alerts the user or not. Here it is. You can see the device starts alarming when chemical level exceeds the threshold level, and also the pump is switched off automatically by the automatic power off system. So it works perfectly. You can also see that I have received alerts through SMS from the Bolt Python library, warning me that there is a malfunction in the system and emergency shutdown has been initiated. You can also monitor the tank level every minute through the graphs produced by the BoltWifi module in the Bolt Cloud web page. As you can see, I have downloaded the data of various tank levels of various time periods through the Bolt Cloud web page. And to make this project more compact, I have designed this whole circuit in a GCP board. You can see this is the Bolt IoT module, and this is the 7805 voltage regulator to provide power to this whole board. And this is, instead of Arduino, I have used Atmega 328B microcontroller here, and these are the transistors used to switch those relays. And this is the block terminal through which I have connected the pump with the relay, and I have also connected an 16 MHz crystal oscillator to provide clock pulse to the microcontroller. And these are the male header pins through which we can connect the LCD display. To get more understanding about the Bolt Python library, you should undergo the Bolt IoT and machine learning training.